Good morning, everyone. Thanks for coming to hear us talk a little bit about site selection and how we use machine learning here at McDonald's to optimize our locations. So just a little bit about us. Go ahead, Kurt.
Hey everyone, my name is Kurt Schuepfer. I work as a senior manager of data science at McDonald's. And our team is called the Enterprise Data Analytics and AI team. We're essentially a center of excellence that can sort of work with several functions across the organization. So I primarily my team focuses a lot on supply chain and kind of forecasting processes, but our group covers everything from customer at McDonald's to in-restaurant technology and edge and HR, and we've also worked with real estate as we'll show today. Personally, interested in machine learning and deep learning algorithms. Since grad school, I've always fallen in love with statistics and statistical learning algorithms. These days, my passions are really unlocking the potential in my teammates and also getting more into things like organizational structure and business strategy to keep evolving McDonald's in the area of analytics. On a personal note, just a bit of a music buff. So my wife and I enjoy indie rock shows in Chicago, where we live and work. So if you're a music buff, we'd love to keep in touch and chat after the talk. I'll kick it over to Pat to introduce himself.
Thanks, Kurt. Yeah, my name is Pat Wilkins, also a senior manager on the same Enterprise Data Analytics and AI team as Kurt. My interests include, but aren't limited to, kind of scalable solution architecture, customer and geospatial analytics. Outside of work, I like to be outside, like to fish. Kind of what we chose the kind of about us photos to sort of set the stage on the topic of site selection. When it comes to concert, Kurt wants to pick the venue that maybe sounds the best for the artist that he likes. I might pick a body of water that gives me the best chance to catch a fish that I'm looking to go after. So you might use data like stocking numbers to figure out where to go. I'm sure many of you might have used Google Maps this week to find a place to eat walking around the conference venue, or even getting out here on your flight. I've looked at kind of the seating chart to pick the right seat that you're here to look after, or even just outside. I don't know how many of you went to the Oasis Grill that is right outside, but kind of an optimal site for them this week as well for their business. So kind of talk about that in the context of McDonald's and what that means for kind of their growth strategy going forward. So a little bit about that and the three different areas we plan to cover. The first being kind of McDonald's as a real estate business. Three main things there from kind of the current strategy that the company is called Accelerating the Arches. A big part of that is growth over the next 5 to 10 years. To get an understanding of that kind of the scale, we have roughly $42 billion of value that are either kind of property or equipment related, and kind of beginning the fastest growth phase in company history there. The second one, leveraging kind of machine learning and AI methods across the business. We'll talk a little bit about the problem statement, the data we used, the methodology, and kind of the current results in terms of where we're at and where we hope to improve in the future. And kind of the last piece, we'll touch on this a little bit, kind of as we highlight how McDonald's has grown over the years and what that means to kind of operate more as kind of one McDonald's way of working in terms of digital standardization as we've scaled across the globe, kind of focusing on where we can to consolidate and be more efficient at scale. It's kind of a key component to that first step to quicker innovation in the future. So yes, next slide, just to kind of go all the way back and give a little bit more business context. The first location all the way back in 1955 in Des Plaines, Illinois, all the way up to 2022. We have 40,000 locations now across the globe. Along the way, the first international locations were in Canada and Puerto Rico in 1967. First drive-through was near an Army base in Arizona in 1975. And then you can kind of see from 1988 onward the trajectory we've had in terms of growth in that time period. So kind of going from now to 2027 is to open 10,000 additional restaurants with a focus both in the United States as well as globally, but that will account for kind of the fastest growth phase in history. And kind of to put that into context, that would be, we currently have more locations than Burger King, Wendy's, Taco Bell, and Arby's combined. So kind of, being able to think about that as we talk about some of the methods we've been trying to use to optimize site selection kind of puts into context both the opportunity and the challenges that we face there. So a little bit more about that in terms of the gaps and opportunities. I think, I'm thinking about a company that's grown internationally like McDonald's has. Some of these gaps, particularly when it comes to geospatial analytics, I think isn't uncommon, that there's different disparate data sets across the globe. And as we've scaled, different markets maybe have adopted different methodologies depending on the data availability they have. And, as such, as, things have developed in different markets, the adoption of modern ML techniques maybe has varied as well. Kind of leading then to the opportunities on the same front, wanting to better standardize the geospatial data that we have, as well as introduce scalable machine learning approaches and kind of having one way to measure and optimize the site selection and ultimately the sales estimation that Kurt's going to talk a little bit more about. And then also kind of to have the flexibility as new data becomes available. I think in the last several years, particularly with mobility data and things like that, to be able to incorporate those into our approach allows for only kind of better accuracy and ultimately better value we're given to the business. So with that, I'll kick it over to Kurt.
Thanks, Pat. So before we get into the methodology we used, first helps just to orient to why we're even doing sales estimation at all. Some of this may seem obvious, but as McDonald's, when we're building a new restaurant, we want to make sure we're not going to miss an opportunity, right? We may have a great restaurant and proposed site that we think will be profitable, but we also want to make sure that we're not missing an even more profitable store. So allowing a sort of methodology to efficiently sort of sort and rank through all sorts of sites that we're proposing to the model lets us not miss any opportunities. As well, we want to make sure that our franchisees are set up to succeed. Some businesses will allow franchise owners to essentially set up a shop right next to an existing shop if they wanted to. At McDonald's, we want to make sure that any new restaurant is not going to kind of sap the demand or sort of bump up against an existing store that's already running, or any kind of network of McDonald's in a given area. So we want to make sure that the stores we put in are going to be high performing from day one. And then finally, we also want to make sure that we can negotiate rent well, and this tends to be a long-term contract at McDonald's, so having a more accurate sales figure lets us to do that. One thing I found kind of interesting on this project, and this is a case with anything at this brand, is there's just so much history, right? If you grew up eating McDonald's, it probably has some connection to your childhood in some level. And so it was just like sort of fun to like read through how McDonald's was approaching this like back in the day, right before I was born. And how we used to do it actually was just with simple trade surveys. Like we would go trade area surveys, we would go to restaurants. We just simply ask people things like, where were you driving from? Where were you driving to that made you want to stop at McDonald's? How far were you driving, right, to get to McDonald's? And then we would ask demographic questions and other things. This allows us to really kind of start building these kind of theories of what drove people to certain locations, what the likely customer base would be, and how far people were willing to travel, right, to get to the nearest McDonald's. We also discovered through those interviews that the type of location actually matters, right? So how big your trade area or how far people are willing to drive really greatly depend on sort of how densely populated the area is. You could imagine if you work in some place like a San Francisco or Chicago, you're on a lunch break, you might be, flooded with options, right, within the first 1,000 feet of walking out the door, right? And you're probably less willing to travel much beyond that, right, to have your lunch, right? Compared to like a more rural setting where drive times tend to be longer between things. And so in those cases, we might actually want to sort of widen out the trade area to capture that demand characteristic. So location type tended to matter a lot, and how the population, basically how densely populated or how urban it was. We also learned things like the businesses matter, right? Certain type of demographic more likely to visit McDonald's on their lunch break. So if an area has sort of a greater density of those of businesses, right, attracting certain demographics to their business to work, you're more likely to have sales at lunch hour, right? So the sort of type of business as well as just the number of businesses is going to matter, right? Any number of people across any business are going to go to McDonald's on their lunch break. So those also tended to be sort of magnets of demand for us. Finally, not surprisingly, things like demographic characteristics, what types of people were going to McDonald's. I can tell you it's really, everyone in this room's eating McDonald's across every income bracket, age, race, people are going to McDonald's. That said, we do find correlations with certain demographics, and then also sort of like intersections of those demographics with certain countries we're in that can change the likelihood of someone going to McDonald's. Finally, we don't really touch this in our model, but really hyper-local factors like accessibility actually tend to matter a lot as well. Driving by, we have the sort of iconic golden arches. And if there's any kind of obstruction, right, to the golden arches, it's really important that our development team is aware of that before proposing a site. So again, our model is not that hyper-local, but that is another factor that the development team considers when constructing a new McDonald's restaurant. Overall, our team was brought into this. We saw a lot of good analysis of all these factors going into predicting sales or correlating with first-year sales. There was yet still to be a kind of systematic way to sort through all of it, right? In its most advanced form, there was sort of weighted sums, right? So linear models, and I would say a lot of opportunity to deal with all of the nonlinear interactions, right, that exist among the features. So we saw a great opportunity to bring machine learning into this process and to kind of modernize how the organization was approaching this question. And as Pat mentioned as well, we also have noticed that there's sort of pockets of development teams right all around the organization, and each one is independently doing analysis. So we saw a great opportunity to build a standard global model that can be scaled across countries, and it's kind of written generically so that it's able to hit global scale. Before we get into the methodology, there's a couple key terms just to orient yourselves to that tend to be, that are important for our analysis. First is just a trade area. This is a boundary that encapsulates all of the McDonald's potential customers for that particular store. I've drawn one that's way out of scale here, but that was an example. On the left, you can see sort of the black circle around a potential McDonald's site. And that would capture how far basically customers or most of our customers would be, right, in that trade area. You also can see it's bumping up against a river, so we need to consider all sorts of things about the geography when we're looking to build a new McDonald's. The second concept is just a gap. This is also, think of this as an area of unmet demand. So there may be demand there, it's currently not being served, or it's underserved by existing McDonald's restaurants. And you can see an example, like the red store might be an existing McDonald's restaurant, and the blue store might be a new proposed restaurant. The yellow region would represent some overlap, right, between the two trade areas. So how could we ensure we were not building restaurants, right, that would give us a lot of this yellow region, right, and have a lot of sort of sapped demand? This is something we'll get into. Oops. One thing I found really cool about this project was just the data. Like up to this point, I've done some deep learning on my own and stuff, but a lot of my industry projects were like rows and columns, as like most of you probably are doing in your jobs, right? Rows, columns, kind of standard machine learning algorithms, right? This data was really cool because we use these shape files. So you could think of these as just kind of slices, right, on a map, slices of information. So we may want to know, for example, the road networks around a potential site. How close is the McDonald's to the nearest highway? How close is it to the nearest major intersection that might be a large magnet, right, for someone seeing the Golden Arches and then visiting the restaurant? So we used a lot of kind of distance-based features in the model. We also looked at schools, so where they're going to be demographics of students, right, visiting McDonald's on their lunch breaks or right after school ended. We also looked at population demographics. And for those that practitioners want to get started with this, there actually are free shapefiles online for a lot of countries from a census bureau. So you can actually just go to like the census website and download these and get started. We were able to really go kind of granular with the demographic data. It starts at obviously like the country level, and you can drill down into county and zip, and then essentially get all the way down to what might be like a census block level. So think of your neighborhood. In the Canada market, where we also built this, we had a dissemination area for those in Canada. So we got down to the DA level, and we're able to represent the demographics then at that sort of fine grain level. This allowed us, when building a trade area, as we'll get into, not just to construct a good overall kind of aggregate of the trade area, but also how it was distributed, right? How the population was distributed, and we could sort of downweight or upweight depending on where we believe the demand was coming from in that trade area. We also got into businesses and QSR competitors stuff. So this wasn't always available, like in a time-stamped fashion for us to incorporate, but where it was, we were able to include those data points leading up to the first year sales of a restaurant opening, and then other points of interest. So you could think of like large conference centers like this as being a magnet of demand. And again, this is also actually available. I think there's a Python package that gives you POI data across any kind of latitude, longitude point you're looking at an area. So we also leverage some of those points of interest. Won't go to too much detail on what those were. And then we correlated all this to first year sales, right? Or we built a model to map, right, all of these features onto first year sales outcome. How the trade area was constructed, as I mentioned, was a pretty simple process, really. We just like you could just put a latitude and longitude into the process, and we would then be able to use the census data to get to know what type of sort of urbanicity existed right in that spot. And then we were able to kind of use an API to calculate a driving time radius around that location based on the urbanicity, and that would allow us to draw a polygon that would represent our trade area, our best guess at what the trade area would be. We also weighted some features, not all the features we could, but the demographic ones. So if you see, for example, on the left side, it's hard to read the legend, but those colors represent different levels of income. So you can see towards the center, the star where the new restaurant's going, there's a lot of green dots. And then towards the periphery, you get sort of the higher income demographics, right? And this actually mattered a lot, like the location of our demographics. So one thing we accounted for was just the overlap. Like if there was say like only half of a census block, right, was represented on that boundary of the trade area, we would just weight it less, right? So a good example to walk through this is a very simplified case is the 3 zip codes going into trade area 3. You can see zip code 1, 2, and 3 are all overlapping with trade area A, and so we would simply just use basic arithmetic, right, to weight them based on the overlap area. We also knew from talking with the business that there actually tends to be a decay of demand, right, starting from the center of the restaurant out to the peripheries. So we were able to use packages to kind of build ring-like shapes within the trade area to represent more fine-grained, right, constructs, right, that could give us a better ability to tap into what demographics were actually, right, close to the trade area or far from it. So in this case, we used a simple linear decay. Going from the center out to the periphery. So in this case, on the left, you would see like maybe those higher demographic dots, right? The higher income dots are like the red and the orange. Those would actually be down weighted, right, relative to the ones towards the center. So really just some simple arithmetic and some simple decay functions that we applied to construct the features. But ultimately, we were able to roll this up to get a representation of the trade area as a row. And the approach we took was fairly standard. We did an ensemble approach, so looked at a lot of base learners. Was a lot of rigorous testing on this. We ended up with a kind of stacking approach where we had fine-tuned several base learners and not just get these sort of weighted sum of their outputs, but also then train a meta learner on a couple of the base learners to get a final prediction. This is really helpful if you have models that are making errors in some distinct ways, right? Maybe you have, for example, in our case, like a k-nearest neighbors that's really sort of specialized to handle like local structure in the data, right? And you might want to contrast that or leverage the best of that while also leveraging the best of something more global, like an XGBoost. You can kind of look at the error correlations and see if it makes sense for your modeling approach if you want to kind of do a stacking ensemble approach, which we found successful in this case. We achieved over an 80% R squared on the validation set and around a 78% on test. Often it came down to factors that we just could not collect data for, right? That were driving a lot of differences in sales or a lot of the residuals. But this was enough for the stakeholders to give us their buy-in to kind of move this to the next stage. The other thing I mentioned is it's not just sales forecasts that we're interested in, right? We also want to make sure that if we build a new restaurant, that it's going to actually enhance the overall global system profitability, right? And not just look at only individual store profitability. So in this case, we used an optimization model that was informed by something called set covering theory. I won't go too into the details on this, but essentially, we had a pipeline that would start with our feature engineering process that I just walked through, lead to a sales outcome or a sales estimate, and then we would consider things like the development costs or the operational costs of building those restaurants, as well as the degree of overlap that those proposed sites had with the existing networks of McDonald's locations. And using all of this together, we were able to optimize and rank in terms of the best system choice for a new restaurant. One thing that we'll walk through is just a very simple use case. And you can imagine sort of a boundary around the whole perimeter of this network of restaurants. And by breaking it down, what we did is break it down into hexagons, right? The whole region. And that would comprise a sort of universal set of points for our optimization algorithm. And these hexagons we were able to basically distribute demand, right? Using some logic from the business, distribute it across these proposed trade areas or the existing trade areas. And then look at things like, for that site, how much would it cost to build? How much would it be costing in operational expenses? And then obviously, just like as you can see here, what's the degree of overlap among restaurants? So you can see in this example, opening store 4, which is on the right side of the screen, on stores 2 and 3, there's a larger degree of overlap with store 2. And so that's going to get penalized. That'll penalize in the algorithm. Compared to opening a store 5, we have revenues 1 and 3, as well as the impact to those stores. You can see there's lesser of a penalty in this case. That doesn't strictly mean it's going to be downweighted, right? You can imagine, for example, store 4 having like lots of gap unmet demand in that lower right region of the screen, right? So it really just depends on all of those factors together, how much unmet demand there was, as well as what the penalty was on existing demand and how it was distributed across the trade areas. So all in all, we had a nice end-to-end pipeline that was able to take any latitude, longitude, and or set of latitude, longitudes, and then run through the whole engineering process of getting us features, feeding it into our model, and then sending the output into this optimization layer, which allowed us to get the final ranking of stores. And I will kick it back over to Pat to talk about scaling and what we did as next steps.
All right, thanks. So yeah, kind of keeping with that thought in terms of kind of the end-to-end solution, after more of the proof of concept phase, we were able to build a workflow to kind of support that scaling to multiple markets. So that existed of kind of orchestrating several tasks, if we were to start with a certain market, and once we identified the data that was available in a given area, we could kind of set our configuration parameters to ingest, transform, and create the features needed to train and evaluate the model for that area. And as you can see, that would kind of lead to just ultimately saving off the model object there once we were comfortable with it. And then, following that phase, once the development team had any proposed sites, and those latitude and longitudes would get fed into the pipeline and create the predictions we would need from there. With that being said, there's kind of different things we're considering to make it better as we kind of look to kind of standardize the data, going forward, which kind of leads to the next point in terms of, unifying the analytics across different markets. Operating in up to 118 countries, it's hard to kind of consistently fill out the same matrix of data across every one of them. So, luckily there's certain third-party data set, providers that do make that easier and allow for us to take advantage of, the coverage they have and be able to standardize it. And, fortunately, that's kind of an area we're looking to keep exploring in to make it a little bit easier to scale up globally. One of the areas that is beneficial that we have looked at a little bit as a result of kind of taking advantage of Databricks Marketplace and what that has to offer in terms of accessibility to a variety of different data assets. In particular, we've done some work in looking at the data that is provided by Cardo on Marketplace, and I think for those of us that have worked with some of the different types of data that Kurt mentioned, even things like OpenStreetMap for POI data, that it can be cumbersome to maintain and leverage. So being able to utilize things available on Marketplace and like the spatial features data set that Cardo has kind of allows for that easy aggregation to look at POIs that are segmented across the industries we want to look at that go into the model, as well as some of the key demographics that go along with that as well. And lastly, one other enhancement is as Databricks kind of has worked to incorporate and adopt more of the H3 support for geospatial processing and analytics. For those of you not familiar, H3 is one of the main open source libraries developed by Uber that supports, I think, up to 16 resolutions composed of different cells that allow for the proper spatial indexing. If you think of a polygon and kind of using the lat longs can be more cumbersome, whereas in H3, and there's a few other spatial indexes out there, allows for just easier use and scaling on that front. And we've used, I think Kurt touched on that during the optimization portion of the workflow, but being able to scale that out and also try to use it more broadly for our data sets allow us not only just to use this for the modeling itself, but in terms of broader geospatial data use across the business is definitely something that has its advantage in this area as well. So yeah, wrapping things up, I think a couple different areas. Kurt, if you want to touch on the top, I know.
Sure. Yeah, real quick, as probably many data science practitioners know, feature engineering tends to be a big differentiator with model success. And so we spent a lot of our time meeting with the business and making sure we understood from their experience what were the key drivers of sales. And then also checking those intuitions that they had built with our approach. We found it worth the time we spent to go into feature engineering at the level we did, even running little experiments like with the decay functions we chose for the trade areas proved to make differences in our accuracies. So all those little details matter. And then obviously combining ML with optimization was also really fruitful. I started most of my career doing technical development, would often just stop with machine learning output and say, well, the business, what do we do next, right? The optimization part, having good OR talent will help kind of drive forward that decision, what do we do with this output now? And so I think that's often an underappreciated aspect of data science workflows. So we really enjoyed having the optimization part on there, and it landed well with the business. And then obviously Databricks, couldn't have this talk without plugging the platform. It's a given that we're all here, we all like Databricks, but I just found it super easy to use as a developer on this, and really impressed with how they continue to evolve. So yeah, I just wanted to say I was a fan of Databricks throughout this experience. Made it really easy to work on this project. So yeah.
Yeah, and the last few pieces, I think the first step was being able to showcase, at an enterprise level, the value we could get out of improved sales estimation. Once you kind of could get that buy-in, it led to other things in terms of how we wanted to standardize and bring more data in to improve upon it. So kind of, in terms of the points Kurt just made, kind of everything kind of goes hand in hand in terms of being able to develop and kind of get more buy-in to kind of move forward from there.
With that said, thank you.